Imagine stepping into a world where machines think like the greatest minds in history, doctors diagnosing rare diseases, chemists unraveling molecular mysteries, all without a single human in the room. That's the promise of expert systems, the unsung heroes of early AI that paved the way for today's intelligent tech. Welcome to our AI Fundamentals series presentation on Expert Systems in Artificial Intelligence, a comprehensive guide from early rule-based AI to modern explainable decision support. Today, we'll journey through the core topics: knowledge engineering, inference engines, architecture, and fascinating case studies like MYCIN and DENDRAL. Presented by the AI research team on this fine day, February 25, 2026. Picture this as a bridge between the past and future. Expert systems weren't just code, they were digital apprentices learning from masters. As we dive in, think about how these systems captured human wisdom in rules, making decisions transparent and reliable. By the end, you'll see why they're still relevant in our hybrid AI era. Let's embark on this story of innovation. Let me take you back to the 1970s, when AI researchers dreamed of bottling human expertise like a genie in a lamp. An expert system, or S, is that very genie, an AI program crafted to tackle complex problems and make decisions with the savvy of a seasoned human expert. Unlike traditional software, which plods through rigid steps like a robot on an assembly line, expert systems thrive on explicit knowledge and symbolic reasoning, adapting heuristically to real-world puzzles. At its heart, it captures specialized knowledge in a domain, employs if-then rules for logic, and even explains its thought process, building trust like a wise mentor. Here's how the magic unfolds. The knowledge base acts as the vault, storing facts and heuristics gleaned from experts. Then, the inference engine, the system's sharp detective, applies those rules to deduce fresh insights or conclusions. For instance, imagine a medical scenario. If a patient has a high fever and elevated WBC count, then the diagnosis leans toward bacterial infection with 85% confidence. It's not just computation, it's simulated expertise, turning data into decisions. This foundation set the stage for AI's evolution, proving machines could mimic human judgment in narrow but profound ways. Think of knowledge engineering as the grand adventure of mining hidden treasures from the minds of experts and forging them into a powerful AI artifact. It's the systematic quest to extract, structure, and validate domain expertise, building an operational knowledge base that's the lifeblood of any expert system. Our story begins with acquisition. Picture intrepid engineers interviewing gurus, observing their craft like anthropologists in the field, eliciting raw insights through deep conversations. Next, modeling shapes this chaos, structuring concepts, defining intricate relationships, and organizing logic like an architect drafting a blueprint. Then comes encoding, where these models transform into tangible if-then rules or formal codes, breathing life into the system. But no quest is complete without trials. Validation verifies accuracy with test cases and expert scrutiny, ensuring the system stands strong. Finally, refinement iterates endlessly, updating the base and expanding horizons as new knowledge emerges. The rewards: a robust knowledge base, a precise rule set, comprehensive documentation, and a clever inference strategy. This process isn't just technical, it's a human-AI collaboration, turning ephemeral wisdom into enduring intelligence that solves problems across eras. Let's travel through time to meet the legendary pioneers of AI, the expert systems that first proved machines could rival human intellect. Our tale starts with MYCIN in the 1970s at Stanford, a groundbreaking backward-chaining wizard in medical diagnosis, designed to spot bacterial infections and prescribe antibiotics tailored to patient weight, like a digital doctor always on call. Then, in 1965, DENDRAL emerged as the original trailblazer in chemical analysis, sifting through mass spectrometry data to predict organic compound structures, revolutionizing scientific discovery. Fast forward to 1978, R1XCON, a commercial triumph used by DEC to configure VAX computers, slashing errors and saving millions by ensuring flawless hardware-software harmony. In oncology, PXDES specialized in lung cancer, determining types and stages from patient data and imaging, while Cadet focused on early cancer detection, aiding clinicians in screening like a vigilant sentinel. These aren't just programs, they're milestones in AI history, from medical marvels to industrial saviors, showing how rule-based logic could conquer complex domains. Their legacy, inspiring today's AI, where explainability meets efficiency in ways that once seemed like science fiction. Envision an expert system as a symphony orchestra, each component playing in harmony to create masterful decisions. At the core is the knowledge base, the brain, a vast repository storing domain-specific facts, if-then rules, and heuristics, distilled from human specialists like precious elixir. It's the raw expertise that fuels everything. Conducting this orchestra is the inference engine, the processor. This clever mechanism applies rules to facts, using forward chaining for data-driven explorations or backward chaining for goal-oriented quests, deducing new truths step by step. Bridging the human world is the user interface, allowing everyday folks to input problems, query the system, and receive advice in clear, readable formats, like a friendly conversation with a genius. Finally, the explanation module builds trust, tracing the reasoning path to answer why or how, justifying every conclusion as if recounting a detective's case. Together, these elements form the architecture, from user inputs flowing through the engine, tapping the knowledge base, to outputs enhanced by explanations. This design isn't rigid. It's a living framework, evolving from early AI to modern tools, making complex problem-solving accessible and accountable. Picture expert systems as the steadfast guardians of knowledge in the AI realm, distinguished by traits that set them apart from ordinary programs. Unlike conventional code, they separate knowledge from reasoning mechanics, allowing transparent, explainable decision-making, like peeling back layers of an onion to reveal the core logic. Their permanent expertise incarnate. While humans retire or forget, these systems archive wisdom eternally, easily duplicated and distributed globally to make scarce skills accessible anywhere. Cost-effective? Absolutely, they slash the expense of repetitive consultations with human experts for routine tasks. At their heart is symbolic reasoning, manipulating symbols and rules to mimic human cognitive steps, not just crunching numbers. Explainability shines through, uniquely answering why and how behind conclusions, fostering trust in high-stakes scenarios. Designed for specialized focus, they excel in narrow domains, often outperforming generalist humans with laser-like precision. This story of characteristics weaves a tapestry of reliability and efficiency, from permanence to symbolism, proving why expert systems remain vital in an age craving accountable AI. They're not flawless, but their strengths narrate our tale of targeted brilliance. Imagine a world where expertise is infinite, untiring, and always at your fingertips. That's the enchanting advantage of expert systems. They deliver consistent, emotion-free performance at a scale humans can't match, handling thousands of queries without fatigue, like tireless guardians of knowledge. Low accessibility cost is a game-changer. By eliminating the need for pricey human experts in routine consultations, they drastically cut operational expenses, democratizing high-level advice. Fast response times make them heroes in time-sensitive domains, providing immediate diagnoses or advice without scheduling woes. Emotion-free decisions ensure objectivity, unswayed by stress or bias, leading to pure, consistent outcomes. Their low error rate maintains high precision, reducing human mistakes caused by tiredness or distraction. Explainable decisions build unbreakable trust. Unlike black box AI, they trace logic for every conclusion. And scalability. Knowledge bases duplicate effortlessly, deploying expertise to global units instantly. This narrative of benefits paints expert systems as efficiency engines, from cost savings to reliability, answering why use them, with a resounding tale of amplified human potential in an ever-complex world. Every hero has a flaw, and expert systems are no exception. Their story is one of brilliant boundaries in the vast AI landscape. They lack human qualities like intuition and common sense, becoming brittle when scenarios stray outside their predefined rule sets, like a knight confined to his castle. No true intuition means they can't rely on gut feelings to tackle novel problems beyond programming, sticking rigidly to logic paths without creativity. Narrow scope amplifies this. They perform exceptionally within domains but falter completely if issues drift slightly outside, highlighting rule-based AI's constraints. Knowledge acquisition is a notorious bottleneck. Extracting and encoding deep expertise from humans is expensive and time-consuming, like mining rare gems. Maintenance burdens grow as domains evolve, introducing complex rule conflicts that demand constant updates. Lack of creativity stifles innovation. They follow predefined paths, unable to invent solutions. Handling uncertainty remains challenging, struggling with ambiguous or incomplete data. This cautionary tale reminds us that while expert systems excel in structured realms, their limitations narrate the need for hybrid approaches, blending rules with modern AI's flexibility to overcome these narrow confines. Let's embark on a global tour of expert systems at work, transforming industries like silent revolutionaries. In medical diagnosis, they shine. Internal medicine uses them to diagnose bacterial infections and recommend treatments, as in MYCIN. Oncology for early cancer detection and staging via CADET or PXDES. Analysis for interpreting blood diseases and lab results. Engineering systems tackle fault diagnosis in complex electronics or mechanics, troubleshooting diesel-electric locomotives with maintenance guides, and designed to configure machinery error-free. Software and IT benefit from project risk assessments for development timelines, configuration of compatible hardware, software like R1, XCON, and automated debugging for code errors. Scientific research leverages them in chemistry to identify compounds from mass spectrometry data, as DENDRAL did, or genetics for planning experiments and analyzing molecular structures. Agriculture thrives with crop management forecasting damage from pests or weather, and advisory systems recommending fertilizers and planting schedules based on soil data. This epic narrative spans domains, showing expert systems as versatile allies, from healing bodies to cultivating fields, proving their real-world impact in specialized, high-stakes applications that amplify human capabilities. Dive into the riveting origin story of MYCIN, the 1970s expert system that revolutionized bacterial infection diagnosis, like a detective novel where AI cracks the case. Step 1. Knowledge collection, gathering symptoms, causes, and diagnosis patterns from medical experts, like assembling clues from seasoned investigators. Step 2. KB creation, encoding over 600 if-then rules with certainty factors, building a robust database of medical logic. Step 3. Problem input, where users feed patient history, symptoms, and lab results into the system. Step 4. Interactive Q&A, with MYCIN asking targeted questions for age, weight, and context to refine its logic, much like a probing interview. Step 5. Inference process, using backward chaining to match facts to rules and diagnose infection types. Finally, Step 6. Output and explanation, recommending drug dosages while detailing the reasoning path for transparency. The outcomes: precise infection IDs, therapy plans with certainty factors, and why explanations that build trust. This step-by-step saga of MYCIN's development illustrates knowledge engineering in action, from raw expertise to life-saving advice, setting a blueprint for AI systems that diagnose with doctor-like precision. Behind every expert system lies a human ensemble, a collaborative cast turning ideas into intelligent reality, like a theater troupe staging a masterpiece. Enter the domain expert, the source of knowledge. A skilled professional with deep domain experience, providing factual insights, heuristics, explaining reasoning, and validating solutions for accuracy. They're the raw ore from which the system is forged. Next, the knowledge engineer, the architect and builder. This technical wizard interviews experts to elicit wisdom, encodes logic into the knowledge base, tests and refines the inference engine, translating human thought into understandable rules and structures. Finally, the end user, the beneficiary, often not an expert themselves, they input problem data, interact via the user interface, and apply the system's advice to real tasks, reaping the benefits in practical scenarios. This story of roles weaves a narrative of synergy, the domain expert's wisdom, the engineer's craft, and the user's application, highlighting how human elements are indispensable in development. Together, they ensure the system not only works but empowers, bridging expertise gaps with collaborative ingenuity. As our journey through expert systems draws to a close, reflect on the pioneering success. These were the first to prove machines could replicate human decision-making in domains like medicine and chemistry, laying AI's foundational stones. Transparency is critical. Unlike black box algorithms, they offer clear why and how explainability, essential for high-stakes, regulated worlds. They complement modern AI today, often combined with machine learning for hybrid systems that blend data-driven insights with logical governance. Knowledge is key. An expert system's triumph hinges on quality knowledge engineering, capturing and structuring human expertise accurately. In summary, expert systems laid the foundation for today's intelligent technologies by preserving human expertise in a structured, queryable form. They continue to provide reliable solutions where logic and auditability are paramount. From MYCIN's diagnostic prowess to hybrid AI's future, this tale reminds us that rule-based systems aren't relics, They're evolving chapters in AI's grand narrative, ensuring explainable, trustworthy intelligence for generations to come. Thank you for joining. Let's discuss how these insights shape tomorrow's innovations.